All right, let's look at another example. Here we're going to practice looking at an experiment and going through the entire set of questions. First, we need to identify that it's a binomial, then we'll look at how to use our newfound knowledge of the binomial to answer the question. So when looking at a person's eye color, it turns out that 1% of people in the world have green eyes. So let's consider a group of 20 randomly selected people. Okay, first, explain why this is a binomial. Remember, we want to go through our 4 criteria. Okay. So first, we have n equals 20 trials. That's a fixed number of trials. So next, what we want to do is determine whether or not the trials are independent. That means that if I know the results of the first trial, does that tell me about the next trial? So imagine that you've selected 20 people. If I answer whether or not the first person has green eyes, does that tell me about the second person? No, so we can say, all right, the trials are independent. Next, what we want to do is make sure that there are 2 possible outcomes. Now, this can be confusing because depending on how the experiment is worded, we might have many possible outcomes for the experiment, right? A lot of responses. So for example, if I'm looking at people's eye color, right, we could get lots of different colors that we report. However, if I want to look at whether or not somebody has green eyes, I could phrase that as a yes-no question. Do they have green eyes, yes or no? And so then there are 2 possible outcomes. Green eyes or not green eyes. And then the last criteria is that the probability is the same for each person. And in the problem, we read that there's a 1% of the people in the world have green eyes. So the probability that a randomly selected person has green eyes is 1%. That will be the same for everybody. So this is a binomial experiment since all of the properties are met. So now what we'll do is we'll state our random variable. Okay. So the random variable x is going to be, remember, a numerical measure of the outcome. So even though we're asking a yes or no question, do you have green eyes, x is measuring how many people said yes. So the number of people with green eyes. Or you could say the number of the 20 randomly selected people who have green eyes. So first, let's find the probability that none of those people have green eyes. So what we're looking for is the probability that my random variable x equals 0. Okay, since this problem has the event that x is exactly equal to 0, we're going to use the binom PDF command on our calculator. So we go to distributions, select binom PDF, and we fill the things in. So I'll walk you through that. Second, distributions, find my binom PDF, scroll up or down, and I fill it in. Now remember, in this experiment, we said that we had n equals 20 trials and the probability of success p was 0.01. So we want to make sure we have 20 trials, p is 0.01, and we're looking for the probability that we get our random variable x to be exactly 0. So we want this to say binom PDF 20, comma 0.01, comma 0. And I get a probability of 0.8179. So the probability that x is 0 is 0.8179. The way that we could interpret this is that there is about an 81.79% chance that in a group of 20 randomly selected people, none of them will have green eyes. Okay, let's look at another question. Let's find the probability that at most 3 of them have green eyes. So at most 3 means that 3 is the highest number of people with green eyes that we'll have. So we could have 0, 1, 2, or 3 people that have green eyes. So writing that as a math statement, we want to find the probability that our random variable x is less than or equal to 3. when we're looking at a range of values for our binomial random variable, we use the binom CDF command. CDF stands for Cumulative Distribution Function. It adds up as you go. So when we look at the binom CDF, what we're doing is we're adding up the probability that x is 0 and 1 and 2 up until whenever we reach the value we're looking at. So what we're going to do is we're going to go to the distributions menu and we're going to select the binom CDF command, and we're going to enter in n is 20, p is 0.01, and x is 3. So showing you on the calculator, go to distributions, binom CDF, and again, if it gives me menu style, I'll say 20, 0.01, and 3, or if it just pops it up on the screen, we type in 20, 0.01, 3. Okay, and in this case, it looks like it is a near certainty, 0.999957. So I can write 0.99996. If I'd like to interpret that result, I could say, well, there's a really good chance. There's a really good chance that in a group of 20 randomly selected people, at most 3 have green eyes. We want to be a little bit careful. In the last example, we rounded to 4 decimal places, and we usually will, but it's a little bit tricky when we write a probability as 0 or a probability as 1, since a probability being 1 means we're guaranteed that that will happen, and that's not really the case here. And likewise, if I had a really small probability and I wrote 0, that means that that event is really impossible. So we want to be a little bit cautious about writing exactly 0 or 1, so be careful not to round too much.